Hey, hello and welcome back to another one of these A-level maths videos. So today we're going to be doing the, again, statistics, but we're going to be doing box plots. So this is actually a really short section, so it should only be maybe a 20 or 30 minute thing. But effectively, box plots comes straight back, and just so you know, the way that the mechanics and statistics exam is structured, so paper 3, is there is guaranteed to be a box plot question. Okay, so there's a histogram question, a box plot question. There is always going to be a hypothesis testing question as well. Okay, so the actual kind of questions that come up are always guaranteed. Okay, so box plots is one of them. So we need to make sure we can get all 8 marks in these box plot questions, even if you think they're pretty easy. Okay, let's just get into it. So in a study of how students use their mobile telephones really. The phone usage of a random sample of 11 students was examined for a particular week. The total length of calls in Y minutes for the 11 students were, and the median and quartiles for these data. So, the quartiles are Q1, Q2 and Q3. To work out Q1, all you need to do is take the number of pieces of data and divide it by 4. Now, if you have an odd number of data, you're actually going to add 1 to this. Okay, so that's also the same as just rounding up. So in this case it'd be just 3. So all we're doing is we're looking for the third value, okay, which is going to be 1, 2, 3, 35. And again, we always start from the lowest side. So then Q1 is equal to 35. Q2, you take the number and you half it, but again, if it's an odd number, we're going to add 1 and divide it by 2, which gives me 6. The other way to do this, by the way, is kind of the classic way of cancelling from both sides, right? So you can just kind of go through and then mark them off one by one. 2, 3, 3, 4, 4, 5, 5, and then therefore 53 is your answer. That's also the same as doing this. So you have 1, 2, 3, 4, 5, 6. So both answers give you 53. And lastly, for Q3, you have to do 3n over 4. So again, we're going to add 1. So you can do it after the fact. So 3n times 11 plus 1 over 4. 33, 34. And work that out. But again, we're just looking for 3/4 of the values. One other kind of top tip I can give you is, if you notice, the spacing between all of these is actually 3. Right? 3, 6, 9. So you can just kind of add 3 on, and which should make sense, right? So if we're taking 3/4 of 11, obviously 11 isn't divisible by 4, but 12 is. So the first 3 numbers are 35, then another 3 numbers 53, another 3 numbers gives us 60. So those are our quartiles. Part B basically says you need to find all of the outliers. And to work out an outlier, it's any number that's bigger than the upper quartile plus 1.5 times the interquartile range. So a good thing for us to work out right now is the interquartile range, which is just Q3 minus Q1, which is 60 minus 35, which is 25. Okay, so the kind of upper bound for the outliers, so I'm going to write U outlier just for upper outlier. It's going to be Q3 plus 25, so that is 60 plus 25, which is 85. Okay, and smaller than Q1, so lower outlier is Q1 minus 25, so that's 35 minus 25, which is 10. So anything bigger than 85 or less than 110. So if you look here, less than 10. So there's no numbers less than 10, but there is a number that's bigger than 85, that's 110. So 110 is the only value that fits the criteria. Okay. Lastly, we're actually going to be drawing a box plot. So what we need to do here is, a box plot is consisted of the 3 quartiles and the highest value and the lowest value, and then also any outliers. So With 110, we're not including it yet. So if we're drawing a box plot, what we can do here is, if we want to use the entire space, we're trying to go all the way from 17 to 110. How many boxes do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we can go up in tens if we want to. So we could start with like 10 here. I think we can start with 0, but let's do here 10, 20, 30, 40, 50. Yeah, we could have actually started on 0, but that's totally fine. And all we need to do is plot the values. Now, 110, even though we're not including it, we need to include it on our box plot. You mark outliers with an X, okay? And then all we need to do is add the lowest value. So the lowest value is 17. So this goes up in 2s, right? 2, 4, 6, 8, 10. So 2, 4, 6, 8. So it would be halfway between those two boxes. And let's line it up nice and neatly. One more. Cool. Biggest value is 77, so let's look at 70. So 72, 4, 6, 8, so it would be one little bit below that. I think I actually went slightly too high, that's perfectly fine. And then you just need to put the upper, lower and median, so middle quartile. So Q1 is on 35, so 2, 4, so halfway here. So I draw them slightly smaller. Q2 is 53, so 2, 3, cool. And Q3 is 60, that's a nice easy one. Then you join up the box and add on the whiskers. There we go. And that will give you the full 3 marks. So again, you need kind of a good spread on the axes, which you do need to label. You need to include the outlier and then just accurately plotting those values. So again, every year a box plot question has come up, so you should definitely keep that in mind. Again, we have in a study of how much time students spent on social media. Usage of a random sample of 15 students was examined for a particular day. Total time of usage X minutes for the 15 students were, and then all of this. So also in terms of like writing like a title, sometimes they give it to you, or you can just include it yourself. So we can even put like, which is totally fine, but you don't actually have to. And we have all those values. Find the median and quartiles for this data. Show that there are no outliers. Draw a box plot. Easy. So again, it's a very, very similar thing. So if we start with the median, Q2, right, that's n over 2, but again we've got 15, so we're going to add 1 to it. So we're looking for the 8th value. 1, 2, 3, 4, 5, 6, 7, 8, which is 94. Q1. Again, we're going to do n plus 1 over 4, which is the 4th value, equals, yeah, 4th value, so 1, 2, 3, 4 is 62. And again, if you notice, we can actually kind of skip this point and just go straight to it being the 12th value, because the difference between them is 4, so it should go up by 4 each time. 12th value, and again we could just count 4 from the left, by the way, from the right. But 1, 2, 5, 6, 7, 8, 9, 10, 11, 12. So again, that's the same as doing 4 from the right. So there's a few different ways you can kind of make it a bit easier for yourself. And that is the full 3 marks. So again, it's not too tricky, but because students tend to not really practice it that much, they tend to make a few small errors. So part B, and this is a question I get quite a lot, is what if they give you no condition? Well, on the bright side, at the beginning of your statistics paper, they should tell you the condition for the outliers. But if they really don't tell you anywhere for some arbitrary reason, it's going to be exactly as it is in this question. Okay, 1.5 times the interquartile range, above the upper quartile or below the lower quartile is what we're looking for. interquartile range is 94 minus 62. And if you want, we can even do 1.5 times the interquartile range and work that out. So that would be 32. That would be 48. So what we're looking for is values that are 48 bigger than the upper quartile. So 159 plus 48. And again, we can use calculators for this because, of course, it's a calculator exam. 159. Just to be a bit lazy, 207. So we're looking for anything that's above 207. If we have a look, above the upper quartile. Yep, that should be fine. Oh, I see. I made a small mistake because I didn't do this one properly. It's 159. I got the wrong interquartile range. That's because I didn't do it in the normal order. Normally I would do Q1, 2 and 3. But I decided to change it and I'm paying the price now. So in actuality it should be 97. And then, yeah. So times 1.5. 145.5. Yeah, that makes more sense. Whoops. So looking for everything that's bigger than 159, which is 304.5. So anything bigger than 304.5. And now I should see, yeah, there's nothing bigger than that. And also less than Q1 minus 145.5. And if you notice, this is going to be a negative number. So 45.5. So anything less than that, which of course there is nothing for either because you can't have a negative number of minutes, right? That doesn't make any sense. So hopefully that makes sense for part B. And for part C, once again, draw a box plot. So again, these questions are a bit formulaic. Now, I will say be careful. Depending on your exam board, but also in more recent years, they've actually added parts D and E. So what they might do, and what they usually do, is they give you another box plot for part D, and they'll ask you to compare it. Okay? And they can also ask you to do something called interpolation, which if you've started to watch this video, you might be wondering, why I haven't included that yet. That is because that is actually a separate statistics topic, which we'll go through next week. And interpolation basically is how you read certain values. So it's the opposite of extrapolation. Extrapolation is going outside the data range. Interpolation means you're going inside the data range, which is part of histograms, and it can come up in box plots too. But that's why it may be slightly cut off. So sometimes you can get a few extra parts. Comparing and also interpolation can come up. But again, we need to go through this before we do interpolation because this is kind of the key thing that we need to know. So, part C, drawing the box plot. Lowest value is 6, highest value is 251. That's a pretty big range. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we probably need to go up in like 20s. But even then we're not going to have much space, so maybe 30s or something like that. Because if we went up in 20s, that wouldn't be enough, would it? Because it'd be... Unless we started... No, we can't start on 20. What am I talking about? 0, 20, 40, 60, 80, 100, 20, 40, 60, 80, 200, to 20 to 40, yeah. So we have to go up in 30s, which is a bit of a pain. I mean, 25 could work. 25 would work. Would it be... And it would be easier, yeah. Let's do that. Again, I've shrunk this paper down so it isn't the cleanest. It's damn near perfect. Good. Okay, this is pretty good so far. And again, all we're going to do is translate the information. So once again, there are 5 gaps between this, so each one little box is actually worth 5 points. So 6 is going to be just after the first point. So if we kind of look really carefully here, with that. That's the lowest value. The highest value is 251, so that'd be just a smidge after 250. So we can do it like this. Then we have the lower quartile, which is 62, which is going to be... Okay, this one's actually a bit more interesting. So 55, 60, so it would be just after this second one here. Then we have the median, which is 94, so 75. We have 80, 85, 90, 95, so it'd be ever so slightly before then, so we can make it virtually on top. Then we have 159, which is going to be, so 150, 155, 60, so just before then. So again, these box plot questions come up every single year, guaranteed. It's going to be one of the questions on your statistics paper. And again, if you don't believe me, you can go back and have a look through all of the paper 3s. And you'll find that box plots come up every single year. So it is very important for you to kind of get good at this and understand this. But that is what you're going to have for the box plot in this case. And again, we need to go through this before we go through interpolation. Sometimes there's a, well, usually there's a part D/E. D is comparing two box plots, and E is normally interpolating a box plot, so keep that in mind. And yeah. And here we go. So here's a slightly different question. So again, it's still a box plot question though. So let's have a look-see. Children from two schools, A and B, took part in a competition to complete a puzzle. Their distribution of times taken to the nearest minutes by children in school A was shown in the box plot. So again, keep in mind, I'm just going to say it one more time, these box plot questions come up every single year in your exam. So we get this box plot, okay, it looks pretty easy to read. It seems to go up in less than, it goes up in 0.5s actually, which is quite interesting. Write down the time by which 75% of the children in school A had completed the puzzle. Now this is a key thing. 75% of the children refers to the upper quartile. Okay? So remember, that's why we take 3/4 of the total number, because Q3 is 75% of the children. So all we're doing is basically reading off this value. Now I just said that it goes up in 0.5s. So 15.5, 16, 16.5, 17. So the answer is 17 minutes. Okay? Part B, state what the two crosses represent on the box plot above. Interpret these in context. So again, statistics has a lot of context associated with it. What this means is that the children are outliers, so they are outliers. So in this specific sense, because they are outside the range in terms of the upper limit of it, it means that the children, actually let's write these children, make it a bit more fancy, these children took far longer to complete the puzzle than the other kids. Right? So again, with statistics especially, and in your exam, there is a heavy focus, so normally at least 2 marks per question that come where you have to interpret the results. So hypothesis testing is a big one, right? You have to interpret the results. And this is another case like that, okay? So in this case, if you have a look, they're outliers on the larger end of the larger end of the scale. So in this context, it was a competition to complete a puzzle. So those 2 children took far longer to complete the puzzle. Why? Because they're outside of the upper limit of the outlier. Okay? They took significantly longer than the rest of their peers. Cool. Part C, for school B, the shortest time taken was 6, longest was 22, and the quartiles were 12, 15, and 17. Determine if there are any outliers. So remember, the formula for outlier for us is it's the lower quartile minus the interquartile range, which is 17 minus 12, which is going to be 12 minus 5, which is 7. Okay, the shortest time was 6. It's minus 1.5 times that, sorry. So that would be 5, that would be minus 7.5, which would be equals to 4.5. So, no. And then there's also going to be 17 plus 1.5 times 5, the interquartile range. So 1.5 times that would be 7.5 So it'll be 24.5. And the longest time taken was 22, so no. So that's 3 marks. You get 1 mark for working out each outlier, and then another mark for getting the right answer. So draw a box plot to represent this information. This shouldn't be too tricky. All you need to do is write it down. So box plot, cool. Look, shortest time was 6 minutes. So it would be 5.56, so it'd be 2 squares along from there. So again, I like to go towards the middle. Longest time was 22, so that'd be 4 squares off from 20. So 1, 2, 3, 4. Oops, let's do another line. And the quartiles are 12, 15, and 17. So the 15 one we can do straight away because that's quite easy. And 12 will be 4 from this one, so 1, 2, 3, 4. And 17 would be 4 from this one, so 1, 2, 3, 4. Again, rulers are your best friend. So it looked like that. And now it says compare the 2 distributions. So what can you tell from a box plot? So there are 2 things that you should be talking about for box plots. Okay. The first thing you want to do is you compare the average, which of course in this case is the median. And the next thing you have to compare is spread, which in this case is the interquartile range. Okay? When you're comparing box plots, this is all we're going to be using. Which one has the higher median? Which one has the bigger spread? That's all you need to talk about and you'll get the full 3 marks. So in this case, the median's 15. In this case, the median is 14. So for the first bullet point, and this will be for the first set of marks, is that the median for A is 14 and for B is 15. So B has a greater median. On average, the children took longer in class B than class A. Okay? Easy as sin. That's all you need to do for that part, okay? Then for the spread, this is where things get a bit more interesting. You have to work out the interquartile range, okay? So, interquartile range for A, let's work interquartile range for A was 17 minus 11, which is 6 minutes. Interquartile range for B, we worked out up here, was 5 minutes. So the data / times are more spread out for children in class A. And that's it. So again, you do get marks for working out the interquartile range, but this here gives me 3 marks because we have this comparison. That's all you need to talk about, median and spread. So average and spread, and that's all you need to do. Anyways, that's it for this lesson. So again, we are doing shorter lessons for statistics because they can be a bit of a pain. But I want to reassure you that next is going to be interpolation and standard deviation, which is significantly more difficult, so it should be more interesting. And then we have correlation and regression before we move on to kind of probability, which is where things get harder, then hypothesis testing, which is even harder, and so on. So anyways, I'll see you next week.